Okay, next I am going to explain three problems. Question number 6, 7 and 9. 6, 7 and 9. Actually, it's almost all these three problems has to be solved in the same manner. That's why I'm going to combine all these three questions. Now, the thing that I'm going to explain is an application problem from this chapter, development of surfaces. Now read the question. Solved is a cone. Now I'm not having a cone, so just I'm showing a pyramid. Just assume that this is a cone. Okay. In the question it is said that an ant is starting from a point on the circumference of the cone. It is moving around the cone and then it is reaching the starting point itself. Okay, ant is starting from a point on the circumference. It is moving around the cone and it is reaching the starting point itself. And in the question it is specified that the ant is selecting the shortest route. Now ant can select any path. Ant can take a path like this, or ant can take a path like this. It can take any path, but in the question it is specified that it has to select the shortest route. Now in that question you are never asked to draw the development of the solid. You are only asked to find the shortest route of the ant in both the top view and front view. Now thing is, what you have to understand is whenever you are asked to find the shortest route or shortest distance, you have to draw the development of the solid. Then only you will be able to get the shortest route of a path. Okay, coming on to our cone. So we are having a cone. Diameter is given the question to 60 mm, height is given 70 mm. Okay, and it is said that and is starting from a point on the cone of the circumference of the cone. It is moving around the cone and reaching the starting point. Now, the logic behind finding the shortest distance between 2 points. The logic behind finding the shortest distance between 2 points. Suppose you are having 2 points in space, and if you want to find the shortest distance, if you want to find the shortest distance between 2 points in space, what you have to do is you have to just join using a straight line. That is how we will be finding a shortest distance between 2 points. Use the same logic here. Okay. The starting point and finishing point you have to join it using a straight line, then we will be getting the shortest route. But the problem here is the starting point and finishing point is the same point. That is, we are assuming that the ant is going to start from A. It is moving around the cone, it has to reach A itself. Okay, so the starting point and finishing point should be the same. That means we have to join same points using a straight line. A same point using straight line. That means that point should be getting repeated. A point is getting repeated only in development. Okay, so whenever you have to find the shortest route, you have to always start from the development. Okay, always join the starting point and finishing point using a straight line. So I am joining capital A and capital A using a straight line. So this will be the shortest route of the ant in development. Now in the question you are asked to find the shortest route of the ant in top view and front view. We have to transfer these points to top view and front view. Okay, you can see that the ant is starting from A. Next point is passing through OB. It is passing through OC. It is passing through OD. Similarly, it is passing through all the generators. And at the end, it is reaching A. So this is the shortest route. What we are going to do is, we are going to transfer these points to front view first and then to top view. The steps that we are going to do is the exactly reverse of what we have done in the previous problems. In the previous problems, we had points in top front view. We were transferring it to development. Now here we are having points in development. We will be transferring it to front view. Okay. So what I am going to do is, I am going to start from A. So our starting point is A dash. Our ending point is also A dash. Okay. I am going to start from this point. This point is lying on OH. So using your compass, you take O as center and this distance as radius. O as center, this small distance as radius, you rotate it. O center, this distance is radius, you rotate it. Now the specialty is, if you have drawn the generators correctly, it will pass exactly through the point that is passing through OB also. If you are rotating this point, it will pass exactly through this point also. Don't stop rotating. You continue rotating till the starting of the development. Okay, so these 2 points are now lying here. Actually, this point should lie on 2 generators. It should lie on OB and OH. That means in front view, it has to lie on O dash B dash and O dash H dash. So you transfer it horizontally to the corresponding generator. Okay, so this was my point. O as center, this distance as radius, I rotated it using a compass. That arc will exactly pass through OB. You continue rotating it till the starting of the development. From there, you project it horizontally till the corresponding line. This is lying on OB and OH, so it has to be projected till O dash B dash and O dash H dash. Actually, we are doing the same steps but in the reverse direction. Okay, next. Look at these 2 points. This point, it is lying on OG. Same step, I have to rotate it. O as center, this distance as radius, rotate it. It will pass exactly through the point that is lying on OC. Again, don't stop rotating, continue rotating till the starting of the development. So you are getting a point here. This point has to lie on OG, it has to lie on OC. So project it, you will be getting a point on O dash C dash and O dash G dash. So first point is A dash, second point is lying on O dash B dash, O dash S dash, third point is lying on O dash G dash, O dash C dash. Next one. This has to lie on OF and OD. O center, this distance as radius, rotate it. It will pass through exactly through OD. Continue rotating and then project it. It has to lie on which one? O dash F dash, O dash E dash. And the last point is lying on OE. Again, rotate it. O center, this distance as radius, rotate it, project it. So we are getting points here. So the and is starting from this point. And is starting from this point. Okay. First we will move to O dash B dash. You have to join using a smooth curve, not using straight lines. First we will reach O dash B dash. Then we will reach O dash C dash. Then we will reach O dash D dash. Then O dash E dash. And to the same route but in the back direction. Okay. It will return it to A dash. Okay, so this will be the shortest route in development. Sorry, front view. Now you have to project all these points to the corresponding lines in top view. Starting point is A. This point is lying on O dash B dash, O dash S dash. You project it. You will be getting a point on OB. You will be getting a point on OH. This point is lying on O dash G dash and O dash C dash. You cannot project it directly. You have to transfer it as we have done in sections of solids. Project it horizontally till O dash E dash, project it till OE, and then with O as center, this distance as radius, you rotate it. You will be getting a point here, you will be getting a point here. Okay, for transferring this distance here, I drew a horizontal line till O dash E dash. I will be transferring it till OE, and then you rotate it with O as center. I will be getting a point here, I will be getting a point here. Okay, next point is lying on O dash F dash, O dash D dash. Transfer it, you will be getting here and here. And the last point is OE, you will be getting it here. So the shortest route in top view will be like this. Okay, so this is how the shortest route will look like in development, in front view and in top view. Okay, now read the next question. Okay, same question, same wordings. It is said that the ant is starting from a point on the circumference. It is moving around the cone and it is reaching the diametrically opposite point. So if the ant is starting from A, what is the diametrically opposite point? It is E. So here you have to join the next question. You have to draw it separately. Don't draw it in this figure itself. You have to draw it separately. In the next question, after drawing top view, front view and development, you have to join A and E using a straight line. You have to join A and E using a straight line. So this will be the shortest route in development. Starting point is A, finishing point is E. So starting point is A dash, finishing point is E dash. Transfer all the points I had explained now. Okay, transfer all the points. You will be getting a point here, you will be getting a point here, you will be getting a point here. So the shortest route in front view will be somewhat like this. And the shortest route in top view will be somewhat like this. Okay. Try to draw it by yourself. And the 9th question. Now what I did was I was explaining question number 6 and 7. Question number 9, it is a pentagonal pyramid. Okay, pentagonal pyramid. And you have to find the shortest route. Same steps, you draw the top view, you draw the front view, you draw the development, you join the starting point and the ending point using a straight line. Transfer all the points as we have done here. But here we were joining the points using a smooth curve since it is a cone. In a cone, always you have to join the points using a smooth curve. But when you are going for a pyramid, you have to join all these points using straight line. That is the only difference between this problem and question number 9. So question number 6, 7 and 9. Try to draw it.